Yeah, I've adopted it. All right. Welcome, everyone. We're getting settled. Just to make sure that you are in the right room, this is the Talks 20 stream. It should be in the Secondary Theater, 505-007. We're going to start with a 15-minute talk, and then we're going to move into a round of lightning talks. So this is the best room to be in because you're going to get a lot of different content over the course of the next hour. So that'll be exciting. We're going to start things off with our 15-minute talk. And so I'm going to welcome up to the stage Tifany from ORCID, who is going to talk about ORCID in Aotearoa, New Zealand. Join me in welcoming Tifany.
Hi everyone, I am Tifany and I am going to talk a little bit about ORCID in New Zealand. So, many of you here might be familiar with ORCID or already have an ORCID ID. So if anyone is not familiar, ORCID is a unique persistent identifier, or PID as we commonly call it, for individuals, specifically for researchers, scholars, and innovators. It is free to create for researchers, and it is very easy to use. And it stands for Open Research Contributor ID. So with an ORCID, you have complete control over your profile. It acts like one profile that gathers all of the professional affiliations, research outputs, activities in one place. And being a persistent identifier, it also comes with all of the benefits of being globally unique. Stable, reliable, disambiguates, it's discoverable, it correctly attributes your research, allows automation and interoperability, saves time and money, and is fair. So there is about more than 85% of New Zealand researchers have an ORCID ID. It is a very well-established, trusted, widely adopted digital identifier, and it is a global standard for research IDs. We all want our research to be correctly attributed to us, and organizations should be able to see a researcher profile and trust what they see. So that's where ORCID comes in. It's all about trust. It is open, inclusive, and trusted. So, because of all of that, in order to support New Zealand with the adoption of ORCID, Royal Society Te Aotearoa launched the New Zealand ORCID Consortium in 2016. The consortium is fully funded by MBIE. That is the running of it, the membership for the organizations, and the consortium is there to provide technical support to consortium members and to help them with ORCID integrations, to write to ORCID records, and also we also manage the New Zealand ORCID Hub, which I will talk a little bit more soon. So this map here shows all of our current member organizations in New Zealand. We have 40 members spread all over New Zealand, and we're very proud of having such a well-represented science and research system representation. We have members from universities, PROs, independent research institutes, polytechnics. So different organizations have different needs, and we are there to help them use their ORCID membership as best as we can. So there's 3 ORCID infrastructures, services that is provided. One is the ORCID ID. The ID itself is a 16-digit ID that is unique to you and stays with you, whether you change your name, career, location, unless you don't want it anymore. And then we've got the ORCID record, which acts as a digital CV. It is a profile that is connected to your ID, where you can have your employment, education, funding, and other information in there, or your research outputs. Thirdly, we have the ORCID APIs. They are a set of APIs that ORCID provides to allow interoperability between your ORCID record and a member organization. So ORCID has trust markers. Those are validated items that are written onto a researcher record that can be trusted. So, those are written by a validated affiliation, for example, can be written by a university or a research institute. And these trust markers is what allows us to trust the information that is in the ORCID record. So for example, this is an example of my ORCID record. The information that I have added manually myself, the source comes up as my name. And the affiliations written by an organization will come up as a trusted source with a green tick. So the more the trust markers means more trustworthiness. And with more trustworthiness, you have a better trusted record. So these trusted data accumulate within an ORCID record and then is shared between different systems, like publisher systems, institutional systems, and funding systems. So member organizations have the capability of adding these trusted data to researchers' records. And this is done via a number of integrations. So within our consortia, there is a list of different integrations that are used, or systems. We have majority of the universities in New Zealand use symplectic elements. There's an ORCID plugin for the open journal systems. ORCID Affiliation Manager is a tool that is provided by ORCID. I believe University of Auckland and MB has custom in-house integrations as well. And there's repository systems like ePrints and Esploro, Pure is another system. And last but not least, we have the New Zealand ORCID Hub. So, the hub was developed by members of the University of Auckland and Royal Society Te Aotearoa. It was specifically designed to allow consortium members to productively engage with ORCID regardless of their technical resources. So you might have seen in the map, we have a lot of organizations. Some of them don't have the technical resources to have a costly integration. So this is where this is why the hub was made, to help them with that. So it allows to write into ORCID records. It is recognized as a ORCID certified service provider, and you can log in using to a query or ORCID or your ORCID ID. The code is open source, so we're also proud that there's two other consortia, the South Africa Consortia and Uganda Consortia, have adopted the code and made their own versions of it, which is pretty cool. So here I just want to reiterate again, all of these systems are what are used by organizations to write onto a researcher's ORCID record. So if you're using the ORCID Hub, what can you write with it? You can write affiliations, funding, works, peer reviews, and various researcher properties. And under affiliations, you have employment, education, distinctions and services, and so on. Another item is works, and often when we think about works, especially on our ORCID ID, everyone associates works with publications. But in fact, ORCID allows you to write about 40 different types, roughly 40 different types of work types. So all of them are also available in the New Zealand ORCID Hub. Last year, early last year, ORCID released 13 new work types, and they were to support humanities and social sciences and a various number of other research outputs. As you can see, like images or designs and public speech, anything like that. So we wanted to make sure that New Zealand is very valuable here, so we wanted to make that available in the ORCID Hub, which we updated last year as well. So all of that is available. So how does an organization write into a researcher's ORCID record? There's 4 different ways. The first one is user invitation. So if you want to write into one member at a time, especially for smaller organization, then you use the first step, which is user invitation. The second one is when an employee or a student signs into the hub using the Tifany login, that allows them to have a standard affiliation written automatically onto their ORCID record. The third one is a set of APIs. We have the New Zealand ORCID Hub has its own set of APIs that hub administrators can use and automate their work. And the last one is the most commonly used one, where you want to upload a batch of information into ORCID records. Then that can be done using JSON or CSV file. So I'll just give some examples for the second and the fourth one here. One great example of signing into a Tifany and getting the standard affiliation is actually by University of Auckland. On the Research Hub page, there is an ORCID section where you can go and create your ORCID ID if you don't have one, or connect your ORCID ID that you already have. It will then take you to the New Zealand ORCID Hub page. I do realize the login in red there is very small. I will work on it to make it bigger. But it will take you there where you can log in, and it will give you the option to log in via your institutional Tifany details or your ORCID ID. So if you choose the Tifany one, then your organization, it will then lead to have that standard affiliation written onto your ORCID ID. So this is an example of how easy it is to have, again, one more trusted affiliation written on, trusted information written onto your ORCID record. And this can be done as a researcher, a student, staff, a very easy method to do so. The other option is a batch upload. So the Royal Society of Aotearoa usually uses that the most. We write a lot of funding items, so MBIE and the Royal Society write a lot of funding items onto researchers' records, and we're really proud of it because we are among the leading consortium to actually do so. So a funding item will look like that. And then another example is the Royal Society, for example, does processes like being a panelist on a Marsden Fund. So that can be written onto your ORCID record as a service. Or we award different medals at the Royal Society, and those can be added to the ORCID record as distinctions. We're also responsible for the Prime Minister Science Prizes, so those are also written onto the researchers' ORCID records. And this is an example of an affiliation. So a standard affiliation had just employment and just the bare minimum of it, but the bigger affiliations will have the organization IDs and a little bit more information. So I wanted, the key message that I want everyone to take away here is really the more fully populated ORCID IDs you have and the more integrated all the systems are, then the more value all the stakeholders can gain from adopting ORCID. So from a researcher's perspective, it can be reduced time and administrative burden, saves time, you can do more research. And for an organization, it can be the ability to better understand the impact of the research that they facilitate and fund. So that is the key takeaway, better populated ORCID IDs. And I will leave it at that. Yes. Thank you.
We've got time for a couple of questions. Does anyone have questions that they would like to pose? I've got one to start. Oh, yeah. Here, I'll bring the mic up to you.
Thank you. So with the CSV upload, can you also do a bulk upload of your organisation's bibliographic reference? Publications?
You can, yeah. It is often used for funding items, affiliations. Yes, you can. You can do the bibliographics as well,
Okay.
from what I know. Yeah.
Thanks.
Kia ora. Maybe this is a dumb question. When you're saying you're adding items onto somebody's profile on behalf of, I assume it's by delegation. So you have people who are assigned a delegate or a delegate type access, or indicating who can be upload on behalf of, etc.
Every organization has a main and a technical contact for ORCID, so those contacts would be the ones who would be able to upload it on behalf of, with the researcher's permission, of course,
Yes, a follow-up question.
Yeah.
Is it just one person then who's assigned at an organization who can do that, or can you request additional? So we're working research support in the library. We have a team that looks after profiles and IDs. Can they become delegates then through you, where they can make changes on behalf of?
Yeah.
In addition to that other person.
For the ORCID Hub, you can have as many admins as you would like. So it can be delegated to as many people and trained and added,
Okay, join me again and thank, we'll squeeze one more in.
Just one quick one.
Yeah.
A very newbie question. So it's free for researchers. What about other people, like research software engineers and other people that might contribute to your publication in that ecosystem? Can they get an ORCID ID?
For
well?
ORCID ID, it's free. You can. There's that website. You can go in and register. It takes like a couple of minutes, and anyone can register, even if you're not a researcher. But yeah.
All right, join me again in thanking Tifany. Now we're moving into the lightning talk round, and I'm pleased to welcome Martin from the Archives Library, New Zealand. Over to you.
Kia ora koutou, ko Marty Gengenbach, toku ingoa, and I am with the National Library of New Zealand, or Archives Library New Zealand, depending on where we are in our reorganization. And the National Library is also the consortium lead for the New Zealand DOI Consortium, which I'm here to talk about today. The DOI Consortium has its origins in the same 2016 MB Research Science and Innovation Domain Plan and Consul consultations in 2015-2016 that produced the ORCID Hub and ORCID initiative here in New Zealand. The DOI consortium came online a little bit later in 2019, excuse me, with 5 original members. We are now up to 8 members, or possibly 7 or possibly 9, depending on how you consider the public research organization reorganizations happening. The 2016 domain plan represented a commitment from the New Zealand government and funding agencies to improve coordination of data and information and to lay the framework for developing a national research data infrastructure. So some core components of that infrastructure were support for the adoption of standardized identifiers for researchers and research outputs, which led to the ORCID Consortium and NZ DOI Consortium. So DOI stands for Digital Object Identifier. And there's a bit of a misconception around this because people tend to think that this is a digital object identifier, an identifier for digital objects. While it's true that most identifiers are used for digital objects, they can be for almost anything. So what we're actually talking about is a digital object identifier, an identifier that is digital for objects. That makes sense to everybody, right? Yeah, of course. So this is an example of what a DOI looks like. It has three parts. DOI formation is governed by ISO 26364, which lays out all the fundamental components. You can go read up on it if you'd like. Very thrilling. The proxy, the first part, is not actually part of that specification, but almost all DOIs are accessed as URLs. The prefix is that 10 dot number string, and all DOIs start with that 10 dot followed by a different string of numbers. The prefix is used as a namespace that allows for global uniqueness without the requirement of global coordination. So each organization can maintain their own DOI minting process. The suffix, the last part, is any combination of characters that can be resolvable as a URL. These can be customizable, they can be randomly generated. Resolving the DOI, clicking on the link, can take you to the digital object itself, or it may take you to a landing page containing metadata about the object. So DOIs are designed to help people and machines keep track of things. DOIs help machines keep track of things because while human readable, they're also machine readable and actionable. So you click on the link for the DOI and it resolves. It provides you with access to the resource or its metadata. The DOI itself is persistent, so you can update information about the resource represented by the DOI, such as its storage location, without having to alter the identifier. DOIs are also interoperable, so you can fit other identifiers or other information into the metadata or the identifier itself. I'm going to talk fast now. DOIs are also human readable, so you can see what it is. You know when you see 10 dot whatever that is a DOI. They're persistent, and this persistence can increase the visibility of your research and supporting data. And they can be used to demonstrate research impact while supporting best practices for sharing. DOIs help machines and people keep track of things. But things are not just digital, so it can be physical too, really any instance of intellectual property that you want to document. So physical objects, scientific instruments, research platforms, satellites, telescopes, airplanes, boats, submersibles, you name it. Why use DOIs? As Tifany articulated so well, researchers have a great way to identify and disambiguate themselves in the world through the ORCID. But what about the products of that work? The tools, software, data used to produce that work. That is where DOIs come in. You can join the DOI Consortium to support data sharing best practices such as fair and care, gain access to global data infrastructure with robust tools and services for DOI creation and maintenance, and you join a community dedicated to sharing research outputs and all the other things related to that output through the use of DOIs. Note that it is an organization that can join and that it is not free. It is a member-funded organization to maintain and create those DOIs. We use nifty tools available through DataCite. You may be familiar with other DOI creation platforms such as Crossref. They all sometimes work together very well. What's next for us? We are growing. We are building a community of practice in Aotearoa, New Zealand, and we are forming partnerships with ARDC and other organizations in the region. Thank you very much for your time and attention. Here's a link where you can learn more about the consortium and an email to get in touch.
Thank you.
Thank you.
Yeah, no questions. We'll just go through all the lightning talks, and if you do have questions, I'm sure there'll be time at the end. Okay, next up we have Trish from the Australia Research Data Commons.
Segue, thank you.
Yeah.
Who's after me? How can I segue to them? Let me see.
DairyNZ will be after you.
That might be a bit of a stretch. So, let's see. Sorry, Mac user. Trying to remember how to, from beginning. Dion, thank you. Sorry, I didn't get the instructions that I had to do my own AV. Thanks, everyone. 5 minutes. I wanted to bring attention to IDW 2027, International Data Week. Happened for us last year in IDW 2025, and the Australian Research Data Commons were the host of it. So it was the first time IDW came to our part of the region, and it was really part of ARDC's international strategy to bring IDW here to try to get as many people from Asia Pacific attending the biggest research data conference in the world, really. It only runs every 2 years, and prior to that, well, in previous years, it's been in Seoul, Botswana, and the next one in 2027 is in Cape Town, South Africa. It's usually run hybrid, so at minimum you can join online, but you've got a really great opportunity to look beyond your borders and participate in a global community. So today I'm going to share some kind of lessons learned. So if you are running an event here and you want to reach out to a community in an interesting way, I'll go through some lessons learned and some tips that we went through in promoting IDW, and then I'll finish up with what you can do between now and then to get the most out of participating in this amazing event. So IDW, we hosted it, ARDC hosted it, but the founding members are Research Data Alliance, CoData, and World Data System. So it's really 2 conferences in one. The Research Data Alliance Plenary, and SciDataCon, which runs every 2 years. So every second year, RDA's in-person plenary is at IDW. Sorry about that, guys, my background music. So if you are running a conference or looking to bring in the community in this research space, what we did that was different to just sponsorship and early bird registrations and the usual things around conferences is we had regional champions that we identified as people who could help promote IDW in their network. So these were people from different parts of the world and across the globe. And the year before, IDW already started identifying the regional champions, feeding them the newsletters, updates, speaker information, that kind of thing. So they formed a little mini community, and it was a great way for them to network also amongst themselves. We hosted a lot of information webinars, so IDW did with the 3 organisations, but ARDC also ran a lot of information sessions. I also did information sessions per country or region and invited speakers in their natural language to speak to the community. We had a newsletter update sent every month. And yeah, we pounded the pavement. Any presentation opportunity, every ARDC presentation had the previous slide in the slide deck, and it was mandatory that we all spruiked IDW and tried to get as many people to come around. We had a very strong marketing campaign, good collateral, a very professional marketing team working behind the scenes. and even paid advertising towards the end to try to drum up registrations. And building legacy was another thing. So we had low and middle income country grants that we offered, and organisations and individuals could contribute to that. But we also had the Restoration Fund for the Great Barrier Reef, which raised some good coin. So we had 857 attendees, which was a real success. And it's so great to see that some of you did make it to IDW, because it was like, it was so good to see so many Kiwis there, actually. Now, how do you make the most of it? Between now and then, what can you do? I really urge you to check out the Research Data Alliance, CoData and WDS, very different organisations. RDA is free to join as an individual, and then you can view which groups might be of interest to you, join the groups. At minimum, just get a newsletter once a month, but otherwise you can choose your level, your adventure with RDA. And it is across domains, across disciplines, and it's open to everyone. I encourage you to participate in the virtual plenary that's on next month in March, and then we have the in-person one in October in London. CoData do have the CoData Science Journal, and they are looking for anyone who did participate at IDW. If you did a presentation or poster, submit it to be included in future publications. So the deadline there is March 31st. And you can also nominate for the Data Stewardship Award with WDS, World Data System. That is also open now. And the website for IDW 2027 is still very light because it is a year and a half away, but it is in Cape Town, and judging by the entourage that came at IDW 2025, it's going to be a lot of amazing fun, incredible connection and community. So I'm just going to finish with join us. That's a QR code to check out the RDA. The next month's plenary is virtual, so registrations are now open all the way through, and there will be lots of sessions in our time zone.
Great.
Thank you. Sorry, I couldn't do Dairy New Zealand.
So from there, we're going to move over to hear from Mubashir from DairyNZ. That's my attempt to transition.
Right. Do I need to plug in the USB drive? I would need your help.
Did anyone have any questions for our first couple of speakers? Anyone have any other cow puns?
Can we sing? Can you guys sing?
I mean, we can sing.
Do you want to copy it on? Did you change any of the display settings? You just have to use the clicker. Yeah, good afternoon, everyone.
I'll be talking about the modern science data workflows which we deployed at DairyNZ, and would share some of the lessons we learned along the way which might be useful for yourself and for your organization. DairyNZ, we are a levy-paid organization paid by New Zealand dairy farmers, and our purpose is to deliver a positive future for New Zealand dairy farming, and our vision is to make the levy best investment for New Zealand dairy farmers. Well, to do our job, this is where we want to be, a happy scientist working on computers with their favorite tools, but that's not always the case. Sometimes we are stuck with the tools on the left. You might share the frustration of Excel if you use optimization models or VLOOKUPs and all that. We channeled our frustrations and became bold to have some impact, to get from left to the right. But before getting into that, why the change was necessary. So we worked most of the time with a lot of research data, farm trials and so on. 10 years ago, a multi-year farm trial would generate probably 2 or 3 megabytes of data. 1 or 2 rows of data on daily basis, 600, 700 rows for 2 years data, easily could be stored on a floppy disk if you know what this is. But these days, with the cow wearable devices, not one, but multiple, we generate hundreds of rows every second across multiple columns. So the data starts to add up very, very quickly. And if we collect the data from, modern data from smart devices for just 1 year and put them in a floppy and stack it up, it would go probably higher than Burj Khalifa. So, and other than that, we changed our linear research method to the iterative research method. So linear research method was where the farm trial guys would collect the data and statisticians would run their models, to iterative research model where farm trial guys and the scientists, they work side by side, iteratively, to learn the trends and data and adjust the methodologies and so on. Well, it was a burning issue. So to handle with large data volumes, we needed somewhat robust framework with the technology to be able to import data, run the transformation, do the visualization, do modeling, and communicate results. So we came up with the modern data science workflow, end-to-end data science platforms, which theoretically look like this. We implemented Snowflake for tabular data, Azure Blob Storage for unstructured data, and implemented GitHub Enterprise for code sharing and collaboration, internal and external, and implemented this Opposite Workbench, which is basically RStudio on the cloud, and to do the heavy workloads. And then we have POSIT Connect in place to share the results. What guided our choice for this modern data science workflow? We wanted to have something which fits for purpose in terms of performance, scalability, and reproducibility. And this is a very important one, low cost to start with, to try new technologies. We wanted something which is open source and easy to manage by the IT. And we also wanted to have confidence in vendor with something which limit the technology lock-ins, support open source technologies like R and Python, and most importantly, allies, senior buy-in. So that was the most important one to get there. What we have delivered so far, again, this is just a form of the diagram which I showed earlier. On the left-hand side, we have the users, scientists, statisticians. They have the tools at their disposal, Workbench, to do Visual Studio, R, Python sort of things, POSIT Connect, to deploy the apps, and to communicate results via web apps, schedule reports, and so on to the end users. Well, is our work done? Well, not really. I think it just started. So from Excel to R, it took us about 5 years, and now we have this big journey to deal with AI. And now scientists are not working alone. They are working with AI. So the problem and the method we use to deal with the data and the scope of the problem has shifted. So for example, code generation has become a problem of prompt engineering to describe the analysis precisely for the model, and debugging, syntax error sort of thing became a problem of a logical validation, where scientists, with the assistance of AI, they review the code for methodological flaws. Model selection became a problem of validation, and similarly, analysis became a challenge for the robustness test of AI answers. And execution was used to be build analysis pipelines and do the numbers. Now it's more strategy focused issue. Is the AI generated results are truly defensible or not? So we still have a long way to go. Thank you very much.
Thank you. Okay, now I'd like to welcome up Paola from 21st Century Weather. I say she's going to rain down knowledge on us. Yeah. I'll try to hit it home with the last one.
That's mine.
Yeah, that's in a different folder.
Oh, sorry. Okay. I wasn't here for the instructions. I missed that.
Which one is it there?
Perfect.
Okay, so hello, I'm Pao, and I have a background in atmospheric science. Probably that will explain the motivation for this. I now support researchers studying how the weather is going to look like thanks to climate change. And this presentation is a very, very new project to me. I hope that some of you will be interested in talking about this more in the future. So thinking about climate change is part of my day-to-day work, and in particular, the impact of computing and research is an essential part of the things I'm all the time thinking about. As a research software engineer in climate and weather, I cannot ignore that our own research have an environmental footprint, particularly the energy demand that running these big numerical models that represent the climate and weather have. So to give you an example, I use GADI, the supercomputer at the National Computational Infrastructure in Australia. As a rough estimate, thinking about compute time, GADI uses 14,000 megawatts hour of electricity. This is 135 kilowatt hour in 5 minutes. That's the same amount I use at home every month. So it's a lot, and of that, on an average day, 35% is related to Earth sciences projects, like running these models to do climate and weather. Of course, I am simplifying the problem a lot. Running a supercomputer is not just about the compute time. It's also about managing and maintaining the data centers and keeping everything cool. And there is an even bigger catch here. GADI is located in Australian Capital Territory, and they use 100% renewable energy since 2020. If this was not the case, the energy that GADI used last year will be equivalent to the carbon dioxide emissions of 2,000 flights from New York to Melbourne in just 1 year. Luckily, there are a lot of people thinking about this, maybe not specifically in climate and weather, but in general. From trying to calculate the energy or the carbon dioxide emissions associated to one research project and reporting that as part of a paper, to maybe looking at our code and thinking if we could be doing things more efficiently, or maybe thinking through all the research activities and what's the impact as a research institution as a whole. So, to be clear, I'm not proposing to do less research. That's not the plan. Don't come to me. But can we do more with the same resources we are using today? So my plan for this year is to start that conversation, to bring together researchers, research software engineers, see where we're at, what are the challenges we face maybe locally in the region, and what are the tools that we need in the future moving forward to think a little more about sustainability and the impact of our research. This is part of my Software Sustainability Institute fellowship, and I hope to have more news in the future, including maybe an event to put everyone in the room or a virtual room to have these conversations and keep discussing what else can we do. So if you're interested, let's chat, and you can find me there. Thank you.
All right, and our last speaker in this session, please join me in welcoming Wakas from Academic Fellows. All right, then we have 5 minutes for questions if anyone has anything else they'd like to ask the previous speakers. All right, then you have 5 minutes extra in your mini break, and our final session of the day is going to be in the main theatre, and it's invited talk from Andrea Goethals from the National Library of New Zealand, and then that's going to wrap up the day. So congrats on making it to day 3 in this session, and you have one more to go. So thanks very much for joining us. Oh. And someone forgot their phone. Paola? Oh, that's you? Sorry.